Hey superstars, today we're going to be talking about melting and boiling point, but most importantly, why are there different melting points and boiling points for different substances? And that's going to have to do with intermolecular forces. So we're just going to tiptoe into that idea today. For starters, let's talk about melting point. As you know, we've been talking about phase changes, and melting and freezing point happens at the same temperature. But basically, the melting point of an object is that temp at which a solid turns to the liquid phase. And basically, the two phases are in equilibrium of each other. We have an example here of a couple things. First of all, this ice cube going from solid ice to liquid. You are familiar with every day. We see it all the time, so no big deal. But to the left here, this is actually molten silver. So silver that was solid, heated up enough, given a high enough temperature so that it could turn to liquid. The idea here, the importance is that silver's melting point is much, much higher than water's melting point. And we got to ask, why is that? Why does that happen? Well, hang in there and we'll explain in a second. I want to tackle off the idea of boiling point. Well, it's the temp at which your liquid is going to actually turn to the gas phase. So the idea of boiling and condensing, they definitely have this equilibrium to them where the temperature doesn't change, but there's this constant draw in of heat so that the liquid can turn to a gas. But we know that boiling points are different depending on the substance. So to the right here, once again, is our classic example of boiling water, which we're used to. But something naturally that happens, think about Yellowstone National Park. There's actually sulfuric acid because of the water bubbling through the earth and that comes up to the surface. But that sulfuric acid is actually boiling off as well. So these two objects would have different boiling points, though pretty close together because sulfuric acid has a water base to it. So something to think about. But let's talk about why boiling points and melting points would be different. It has to do with bond strength. The whole idea here is that the stronger the bond is between the substance's atoms or molecules, the greater or higher the melting point will be, and the higher the boiling point will be. Think of it this way. If you have two people holding hands, a couple, and they're holding their hands together really tightly, and you try to run through them like Red Rover style, if they're holding together super tight, you might not break through that bond. You might not give it enough energy for them to stop holding hands. Well, it's the same idea with substances. If the substance is really held together strongly by intermolecular forces, by bond strength, then it's going to be harder to boil them or melt them because the kinetic energy you're pumping into them through heat or whatever is not going to be strong enough to break those forces and bonds between them. So simply stating, the melting point and boiling point, these are physical properties, but because they're different for different substances, we can exploit this and sometimes separate different things that are in a mixture from each other by physical means. Remember, if you're doing something where you have to heat out another substance, the substance that has the weaker bonds, the weaker intermolecular forces, that will tend to boil off first. And speaking of boiling, if you're looking at this picture, let's explain what this is. That picture is all about distillation. And distillation basically heats up a few liquids that are put together in this boiling flask. The gases heat up and eventually travel through what's called a condenser. The condenser is actually cold, so when the gas molecules or particles actually touch the cold glass of the condenser, it turns from a gas back down to a liquid, which is condensation or condensing, and then it falls right back into this Erlenmeyer flask. So distillation is a separating technique. The example we did in class was with alcohol mixed with water and some green food coloring. Now altogether it looked like just one liquid, but when we started heating it around 70-something degrees, the alcohol started boiling up and out of the boiling flask and eventually hit the cold condenser and then dripped back down again into the Erlenmeyer flask. What did it do? It left behind all the water still in the beaker or the boiling flask. So distillation, a simple idea. You're literally heating up objects so that their different boiling points can cause them to separate out. Simple, but very, very useful. Well, that's it for this short lecture today. Just wanted to talk about the differences in that between melting and boiling point between substances. It all has to do with how strongly bonded they are together. Intermolecular forces, the more there's going on, the harder it is to boil or melt something. Have a good one. Thanks for listening.